Good evening. Run. So try these examples. చూసుకోరా First you note down on it, then you try yourself. First you just only one mole is it, not mentioned in excess. In this case, only one mole now. If anybody done first example, please send your answers. Let me check how many members are in the track. Oh, some of them will done that. Yes, Mr. Charitesh, you done the answer none. First one. Okay, so try this one, then we go for the next one. Yes, Sawa? Okay. Hmm. Good. Sequence. ఇది ప్రొడక్ట్ కొంచెం కదా అది అంటే అలాంటిది ఏమో అది కాదు కదా. ఓకే ఇది ఇది కరెక్ట్. ఇది ఫోర్స్ ప్రొడక్ట్ ఏమొస్తుంది ఇది వస్తుంది. థర్డ్ దాంట్లో చేయాలి లేదు ఇక్కడ థర్డ్ ఇక్కడ ఇది అది రైట్ అండి. ఇది ప్రొడక్ట్ ఒకటి రైట్ బాగుంటుంది. ఫస్ట్ రైపో కరెక్ట్ ఆన్సర్. అక్కడే good. So why only at this carbon atom? Why these carbonyl carbon only involved in the reaction? Why not these two? Because these are let down with the drawing group. So the positive charge at this carbon atom is maximum. The reaction comes to this hydrogen cyanide addition reaction. Why aldehydes are more reactive than the ketones? Because aldehydes are more having the more positive center at the carbon atom. That was the reason formaldehyde is more reactive. Generally, in carbonyl compounds, the addition reaction takes place at more electropositive center of the carbon atom. As which of the group will be increase the positive charge on carbonyl carbon atom, that carbon can involve in the reaction first. So, these two are electron withdrawing groups, so pull the electron towards itself. So, the positive charge at this carbon atom is maximum. So, the center carbon atom involved with the HCN can form the cyanoid ring, which on hydrolysis will be converting into carboxylic acid. Now it is alpha, it is beta. Alpha, it is beta. So alpha, beta keto acid on heating otherwise. Hello, Gopal sir. Hello, Gopal sir. Hello, Gopal sir. సార్ నేను బయట ఉన్నాను సార్. అతనికి ఈరోజు రేపటికి ఇంకొక డోనర్ ఎస్డిపి కావాలన్నారు. ఇవ్వండి. సరితే ఆన్సర్ రాని సెకండ్ ఆన్సర్ కూడా రాయి. పని చేసి So all of you check your answers, Nana. Heritage is writing the answers. To try this one, because it's the first year concept of your ozenolysis reaction. Oxidative ozenolysis, if a compound, if any alkene containing of phenolic hydrogen, that will be oxidized into carboxylic acid. If there is no hydrogen is present, then it is converting into ketone. So making on oxidative ozenolysis, the last carbon is converting into carboxylic acid and center carbons are converting into ketones. So with respect to this, it is an acid group, it is an alpha carbon, now it is a beta now. So with respect to this beta keto acid on heating, lots of carbon dioxide converting into ketone. Okay? So this was the answer. That is 2,4, that is hexane 2,4 dione. Hexane 2,4 dione is the answer of second one. You try the remaining one, then we go for the next chemical properties of carbonyl compounds. Okay, I will tell this third one also. All of you get the A. That means all these chlorine atoms on hydrolysis converting into ketones. That is A product. If addition with the KCN reacting with the hydrogen chloride will be converting into HCN. So it is an addition reaction of hydrogen cyanide. Most of you write the answer, but you make little bit mistake. Now at this carbon atom it's a positive charge, right? Positive means cyclopropenyl cation is an aromatic compound. Aromatic compound can form what? No. It forms salt. Positive charge, positive charge, positive charge, positive charge, and they can form as the product with the cyanide. So it is a salt will be formed in the reaction because the center, that is cyclopropenyl, having a positive charge can behave like as the aromatic substances. Aromatic compounds can form the salt. Anirudh, వస్తున్నాయా? Try the remaining reactions. So in last class we discussed about the addition and elimination reactions of the carbonyl compounds, right? So when a carbonyl compound of aldehyde or ketone reacting with the ammonia derivatives, they give the addition and elimination product. What are they now? First one is reacting with the hydroxylamine. I read the mechanism also, what happens in the reaction. So I just write the product in this reaction now. Because in the previous class we discussed about the mechanism while the reacting of carbonyl compounds with the ammonia derivative. NH2OH is known as the hydroxyl amine. Reacting with the any carbonyl compound can form the oxime. If it may be aldehyde or may be ketone. If it is an aldehyde, we can call as the aldehyde oxime. If it is a ketone, it is called as the ketone oxime. Carbonyl compounds reacting with the hydroxylamine can form oxime, whether they may be of aldehyde or ketone. Similarly, reacting with the hydrazine, again removal of this water molecule, and it converting into hydrazone. Zine is converting into hydrazone, whether they may be of aldehyde or ketone. Same thing with the phenyl hydrazine. Phenyl hydrazine is converting into phenyl hydrazone. Phenyl hydrazone. Next, reaction with the 2,4-DNP. 2,4-dinitrophenyl is converted into 2,4-dinitrophenyl It is also known as the 2,4-DNP test. What the name reagent it is? Brody's reagent or Bosch reagent. Generally, it is a orange color compound. When it is reacting with the aldehyde or ketone, it converts into 2,4 phenyl hydrogen of aldehyde or maybe ketone. Two comma four dinitro phenyl hydrazone. It is forms yellow red color dye will be formed. An orange color compound addition with the carbonyl compounds of aldehyde or ketone can give the yellow red color precipitation. This is a question which is asked in viva of your practical examination, because you may have acetaldehyde as well as the acetone. What is 2,4-DNP test? Or they may ask what is Bosch reagent. Among of the table of laboratory, there is a reagent which is called 2,4-DNP. The examiner may ask you, brought the Bosch reagent or Brody's reagent. That is nothing but what? 2,4-DNP. Addition of this to any carbonyl compound, whether aliphatic or aromatic, they may converting into dye. Yellow, red color dye. One more reaction of carbonyl compound with the aldehyde or maybe ketone with semi-carbazone. Semi-carbazide. Semi-carbazide can give addition and elimination product semi-carbazone. All these products can show the geometrical isomerism, that is kin and anti isomerism. The question is, as per your IP, chance to ask a question. In semi-carbazide, there are two NH2 groups. Here is also nitrogen, here is also nitrogen. Why not these NH2 group of hydrogens are involved in the reaction? In semi-carbazide, there are two NH2 groups. That means these two hydrogens, why not involving in the reaction? Because the reason, this lone pair is in the resonance, not available freely. To attack on carbonyl carbon, the lone pair electrons of the nitrogen can be involved first at the carbonyl carbon, which is having a positive charge. But in this case, this carbazide, the lone pair electrons of amide function group is in resonance. That means there is no electrons are available for this nitrogen to react with the carbonyl carbon. So that this carbon atom, this nitrogen atom of lone pair can involve, so it can form as the semi-carbazone. Semi-carbazide is converting into semi-carbazone. Okay? These electrons are amide group of NH2 group of lone pair of electrons are involved in resonance, so that this nitrogen is not behaving like as a nucleophile. If it is in localized at the nitrogen atom, then it is possible to donating of electron to this carbon and form a dative bond. But these are not possible because these are in conjugation due to resonance. Okay, so this is what the chemical properties of carbonyl compound with the ammonia derivative. All these are addition and elimination reaction, and all these compounds can show the geometrical isomerism. Okay, right on. ಹೆಸರನ್ನ to come up for dinitrophenyl hydrazine. Hydrazine ಇದೆ ಇದು ಆದ್ರೆ ನಾನು Bosch reagent or Brody's reagent. 2,4-DNP is known as the Bosch reagent or Brody's reagent. If anybody say if this compound will go for tautomerization, what was the product will be? Nitroso compound. That means it converts into what now? H will be, it's a double bond now, right? So this hydrogen will be exchanged between these two. It converts into what now? Nitroso compound. Possibility of the question. Next, third chemical properties of this carbonyl compound. Reduction. So this carbonyl compound of aldehyde or ketone can give the product depends on the reducing agent. If I use the strong reducing agent like as lithium aluminium hydride or NaBH4, both can be reduced this carbonyl compound into alcohol. If it is an aldehyde, a primary alcohol will be formed. If it is a ketone, it can give the secondary alcohol. Okay, so carbonyl compound on reduction with the lithium aluminium hydride or sodium borohydride can give the alcohol. 1 degree or maybe 2 degree alcohol. Next, a name reaction, what we can call as Clemmensen reduction. We already discussed in your first year now. A mixture of concentrated hydrochloric acid and zinc amalgam is known as the Clemmensen reagent. Right? So, this Clemmensen reagent will reduce the carbonyl compounds. Zinc amalgam and hydrochloric acid, HCl, gives nascent hydrogens. They reduce this carbonyl compound into hydrocarbon. So in place of the oxygen atom, 2 hydrogens are added to the carbon. With using of lithium aluminum hydride or NaBH4, it is reduced into alcohol. But when we use this zinc amalgam and hydrochloric acid, it converting into hydrocarbon. That alkane will be formed. In this, we may have a note. Look at this zinc amalgam and hydrochloric acid. What is we are using now? HCl. So it is an acid sensitive reaction. Acid sensitive reagent. Means along with the compound, if at all any acidic group is present, like as OH group is present, then that can be also removed to give the other product. If it is contain only carbonyl compound, then it is reduced to giving as hydrocarbon. In case if it is containing of any, for example, if it is a compound like this, if I use Clemmensen reagent, and hydrochloric, it is reduced into what now? Hydrocarbon. Along with that, it can form the an alkene. Why? Because the reason this oxygen atom get protonated, convert into what now? As we know, water is a better living group comparing with the OH group. So removed and forms what now? A positive charge. If it is supplying by any hydrogen, it can give cyclohexane. If there is no supply of hydrogen atom, then any of these beta hydrogen atom will be removed, either of the carbon atom, minus of H plus ion, converting into what now? Ketone. So it is an acid sensitive reagent. So to remove this OH group, it is not possible to use the zinc amalgam because along with this OH group is also removed. Okay. Next one. Full stationary reduction. That is a mixture of hydrazine in potassium hydroxide or ethylene glycol. This reagent is also convert the carbonyl compound of aldehyde or ketone N2H4 in potassium hydroxide or glycol, then utilizing of 4 nascent hydrogen atoms, it is also converting into hydrocarbon. What we are using now? OH. It is base sensitive reagent. For example, if the reaction is like this, same example I am using, chlorine or bromine. If I use this reagent, then it can also form the alkene because potassium hydroxide is a base which can remove the beta hydrogen atom along with the halogen. So it will go for dehydrohalogenation reaction. In this case, Nana, dehydration can be taken. Okay? So it is what about the reduction reaction with strong reducing agent. Along with that, we can also use one more reducing agent. Nana. What it is? Hi by red phosphorus. Any function group is converting into, if I use red phosphorus, Hi by red phosphorus, any function group is converting into hydrocarbon. It is known as what, Nana? Bob reagent. because any function group, whatever the function group it may be, it reduces the all function group into the hydrocarbon, so that it is known as the BOP reagent. Okay. Along with that, we discuss some more reducing reagent, that is dibol H, lithium, lithium trite tertiary butoxy aluminium hydride. But these are metal hydrides, will not make the reduction of aldehydes and ketones. They reduce the acid derivatives, like as acid halide, acids, anhydrides, and esters, but not the aldehyde. If it is reduced, what they generally comparing with the lithium aluminum hydride, dibol H, diisobutyl aluminum hydride, or lithium tri-tertiary butoxy aluminum hydride, those are weak reducing agents. It is a strong in nature, so it converts the compound into alcohol. By using of dibol H as well as the lithium tri-tertiary butoxy aluminum hydride, those are also metal hydrides, but compared to these are weak in nature, so they cannot reduce the aldehydes into further carbonyl compounds into alcohol. They reduce acid derivatives to stopping at the carbonyl compound. In case if you use 2 moles of the acid chloride treating with the 2 moles of dibol H at minus 78 degrees centigrade, first it is reduced into aldehyde, then again it is reduced into converting into alcohol. Okay, so it is the third chemical property of carbonyl compounds. Clear? Write down on the first. Carbonyl compounds, carbonyl compounds on reduction with lithium aluminium hydride, or sodium borohydride, gives alcohol. Write the first reaction on with the LiAlH4. One more thing, Nana, to make the confused, they may also give this reagent as La, LeH. Instead of mentioning of lithium aluminum hydride, they may give LeH. You have to assume that that is lithium aluminum hydride. So in this case, what these two reagents are? Aldehyde into 1 degree alcohol, ketones into 2 degree alcohol. These two reagents convert the aldehydes into 1 degree alcohol, ketones into 2 degree alcohol. Next, Clemmenson reagent. A mixture of zinc amalgam, and concentrated hydrochloric acid. Concentrated hydrochloric acid is known as Clemmenson reagent. Clemmenson reagent. Next one. It converts the carbonyl compounds into hydrocarbons. That is alkene. What is the reaction? Next, it is an acid sensitive reagent. It is an acid sensitive reagent. Write this reaction. Next, Wolff-Keshner reduction. Wolff-Keshner reduction. Make fast. Carbonyl compounds carbonyl compounds are reduced to alkanes alkane with alkaline with alkaline hydrazine. Alkaline hydrazine. Write this reaction. It is a base sensitive and then go for the reaction. So in this reaction, to remove the only carbonyl group, what we have to prescribe now? Ulf-Kishner reagent. In this case, to remove the only carbonyl group, we can use the Clemmensen reagent because without affecting of chlorine group. Next, one more, that is carbonyl compound reduced with the Hi by red phosphorus. Also give what name? Alkene. But the reaction. We can also convert these carbonyl compounds with H2 by Ni or platinum or palladium. What we get? The preparation of one compound. How will we get that? Alcohol. They give the alcohol just like as lithium aluminum hydride. They convert into alcohol. Similarly, this carbonyl compound treating with the sodium by ethanol also give alcohol. Can anybody say what is the name reaction it is? Name reaction. Name reaction on anybody of you. Nilesh, Aryan, alcohol. Using of sodium by ethanol, we may get alcohol. Product awesome already. I'm asking what is the name reaction of this one? Bhavana, Jai Sri Ram, Vahini Garu. Most 10 మంది చూస్తాను వాళ్ళందరూ లేదో తెలియదు కానీ మెన్షనింగ్ ఆఫ్ ద నేమ్ ఎవరో రెస్పాండెంట్ చూద్దాం. దట్ మీన్స్ ది ఓ రెస్పాండెంట్. ఎవరిదో నెంబర్. Those processes used for the preparation of phenol, converting of chlorobenzene into phenol by using of sodium hydroxide. Those process kaadu. Hard in blank reaction. Okay, what is before that? Half is correct. Aryan, please avoid blank reduction. Avoid Russian name. One more name. Let me see how many of you will tell the answer. For only this reaction for the ketones, man. Particularly, okay, right, general reaction, then we go for that. May also convert the sodium by benzene. Also give alcohol. It is known as the Jordan reaction. And come to the only ketone. Treating with the aluminium isopropoxide can give secondary alcohol. Anybody of you, what is the name reaction it is? MPV reduction, very good. It is MPV reduction. So these are converting into alcohol. And we see now just which are converting into alkenes. One is Clemmensen reduction, second one is the Wolff-Kishner, third one is HI by red phosphorus. HI by red phosphorus can convert any function group into alkenes. Simple that, look at this Wolff-Kishner reaction as well as the Clemmensen reduction. We just removing of C double bond O. That is, it is also known as a deoxygenation reaction. And what it is converting now, C double bond O, that is the carbonyl group of C double bond O, in converting into what now, CH2, methylene group. So the question may be asked in this manner, if the carbonyl group of C double bond O is converting into methylene group, but what reagents? These three, Clemmensen, Wolff-Kishner, as well as the HI by red phosphorus. C double bond O is reduced to converting into what we are getting now. It is converting into, if you write combining of these two, it is CH2. Okay? So the question may be asked, or they may be giving such type of reactions. So keep in your mind, all these are reagents which are converting into carbonyl compounds, alcohols. Okay? It is the only one reagent which convert the ketones into secondary alcohol. That is MPV reduction. Mervyn Pondorf Wehrle reduction. Okay? So it is what about the reduction reactions of carbonyl compounds. Tomorrow we see about the oxidation properties. You can do, then we can give one more worksheet and assignment is come. చేస్తానండి. To do one thing అన్న, ఇది మీ ఇంటికి రాసుకొని వాట్సాప్ చేసేది. Okay? I'm giving this one assignment to you, Nana, based on the what we discussed from carbonyl compounds or alcohols also. Try this one. I send in your WhatsApp group. Note down first these reactions. And one more thing, Nana, all of you advanced students, listen the class of in the afternoon also, Nana. Because that combining class will discussing about the polymers, biomolecules, and chemistry in everyday life. The portion is similar as per the advanced level as per the general also. Little bit some more importance will be more in polymers as well as in the chemistry in everyday life. So I am giving advice to you before, better to discussing later. You just follow the class which is taking in the combined session. That is in morning, 11:30, 11:45 to 12:30 and 2:30 to 3 o'clock. Okay?